Hello, and today I'd like to go through the latest application from Mooreu. To take a look at the application, please go to your web browser. Go to the web address www.mooreu.com. Hit return. This will open up the main page for Mooreu. Click on the iPhone. This will open up the size and application. You'll notice that you'll see a large white column on your left-hand side. The reason for this column not taking up the full page is so we could have it available for those using mobile devices such as an iPhone or those using Android or BlackBerry. So the first thing I would like you to look at is you'll see in the form you have 4 fields here that really need to be answered in order to size any DC cable. Those 4 fields are the one-way distance from the DC power plant or the DC source to the load in feet along the cable ladder rack. The second one is your loop voltage drop, and we'll talk about what that means in a minute. The max load current in amps, and then your max load current for your voltage drop in amps as well. In order to understand what they mean, we're going to first look at what the ampacity of the cables mean. So this opens up the ampacity help screen, and now you'll be able to see what the max load current amps field represents, and in this particular case that represents the nameplate of the breaker or the fuse that will be tied to that cable that you're going to be sizing. So if you have a 100 amp breaker, you're going to throw 100 amps into the max load current amp field here. Well, a lot of people will say, well, whoa, I don't know what my breaker is. Well, if you don't know what the breaker is, that's okay too, but you are going to have to understand what is the max demand current that load that you're planning to tie to is going to require. Is after you understand what the max load current is, you then have to multiply that by a factor to make sure that you properly oversize the breaker so it doesn't continuously trip. So as you go down through this code down here, we can see that the National Electric Code basically spells out that for a breaker, if it's a continuous load current, they would like to see that breaker oversized by 125% of whatever the continuous load is. So for example, if it's 80 amps and you multiply that by 1.25, that would give you 100 amps. Also, you'll notice at the bottom of this, you'll find the National Electric Code standards as far as how to select the proper ampacity for the temperature, and as well as what is the max current carrying capability of the conductors. So in this particular case, we're only going to be sizing cables from 1/0 all the way through 750 MCM, and I've highlighted in blue the values that we are going to be using for this application to size the ampacity of the wire. So these will be the values that each one run of wire can carry. So for example, a 750 MCM cable, one run can carry a maximum of 475 amps. And everything that we will be sizing for this application is in copper only. So after we have all that information together, we then will go up and we'll look at our voltage drop. Here we'll see the answers to those other 3 fields that we still need to address. The first one is the max load current for voltage drop. So here what we're going to do is we're going to look at the nameplate on the breaker, and going back to our previous example for where we selected the ampacity, where we said it was 100 amps, and we said the reason for it being a 100 amp breaker was because it was an 80 amp max demand load current, and we had to oversize that breaker by 1.25. So in order for us to figure out what is the actual max load current off of that nameplate, we're going to take 100 amps and now we're going to multiply that by the inverse of 1.25, which is 80%. So in this particular field, we will enter 80 amps into the max load current for V drop. We'll then look at the one-way distance. Now this one-way distance is really the distance that the battery or the cable will be going along the cable ladder rack. So it's very important that you understand that it follows the ladder rack so we get the total distance correctly defined. And you would enter that distance one way into the one-way distance field. The last is the loop voltage drop that's required for the calculation. As you might know, an electron basically has to travel all the way along the load cables, around the load, and then back through the return cables. That long path is really an awful lot of loss, so you have to account for that. We have the basic criteria here, which is between batteries and battery chargers, which is also known as your battery cables. The typical loop voltage drop is 1/4 volt. Between your battery chargers and your DC distribution, or your BDFBs or BDCBBs, is your primary cabling, and that's roughly a 1 volt drop, loop voltage drop. And then finally, between your DC distribution and your actual DC loads, which is usually at the top of a relay rack, that's a 0.75 volt, and that's called your secondary cabling. We also go on to define some typical customer standards, so you can take a look at what some other people are doing and the way that they view the way the electrons should flow in their facilities. And then we'll also take a look as far as the calculations that are used to determine voltage drop, which is really contingent upon circular mills, which is a really fancy way of saying the cross-sectional area of the cable. And what we also show at the very bottom is the total number of circular mills that we use for our calculation, as well as the max amperage, as well as total outside diameter of the cable. So if you want to figure out how many cables you'll put on an individual ladder rack, number of layers, you can figure that out. And you can also figure out the total weight per foot. So with all that known, we are now ready to go size our cable. We'll go up to the top of our screen, and you can either click here to size another cable, or you click on the more circle logo. So we're now back in the main field, and we're going to start entering the form data. The first form field is email, and this is the field that you would enter the email address where you would want the report to be emailed to. Most people enter their own email address, which is what I'm going to do here. Enter your phone number and then the project name. The one-way distance, so we're going to say in this example, we're going to be going, say, 70 feet. We're going to be doing a loop voltage drop of, say, 1 volt. We're going to be using a 600 amp breaker, and the max load current, as we know, is 80% of that breaker. So there we have 480 entered. And then which day comes after Monday, we're going to go with Tuesday on that and hit submit. This will open up your email. All we want you to do here is click the email button. You'll see a please wait. And this will then go to the final calculation screen. Here you can review all the information that was entered on your initial form, which would include your name, the calculation ID is now available, the project ID, but we'll also take a look as far as the sizing. In this particular case, the battery sizing that's optimal is 2 runs in parallel of 500 MCM cable. The reason for that is because we base all of our sizing for DC cable based on 2 criteria. The first is based on ampacity, the total amount of current that conductor can carry. And then the second is the voltage drop, which is based on the criteria of the distance, the total amount of amperage that was put in for the voltage drop calculation, and the loop voltage drop. So when we look at the different calculations, we see, oh wow, we see 1 run is only required of 750, but yet you still need 2 runs to meet the ampacity. So 500 becomes the best selection, and the reason for that is because 500 is the smallest size that meets both criteria. As you can see, it takes 2 runs for the voltage drop, and it takes 2 runs for the ampacity, so the minimum that's required is 2. 2 is the smallest number that is required to get it done, so 500 MCM is the optimal selection to get the project complete for the most cost-effective solution. Based on 500 MCM, you then can take a look at the total number of feet that is required to order, as well as the total number of weight. You can also look at the other options that are still available, but they would not make the project optimal. They would still meet the load, but these are not optimal solutions. The only optimal solution is the 500 MCM because it's the least number of runs. The next part of this, you can roll down and you can then look at the different breakouts on each individual cable in the event that you have something that you want to burn up in stock that maybe is oversized. Maybe you want to use your 750. You can do that. This is also a really nice place to see a price quote from us to see if you want to buy the cable from us. And here we'll give you some numbers as far as what we would charge on a per foot basis. To take a look at the email, as you saw popped up on the screen as we were going through the example here, you just open up from the admin at mooreu.com, and this will give you a nice screenshot as far as in all the information that you entered along with the calculations. And the reason why you know that the optimal solution was 2 runs of 500 MCM is because all the other selections are optimal is not 750 or optimal is not 350. We're telling you that that's not optimal. At the very bottom, we also then go into the cable ampacity. So if you need any help, or if you want to forward this on to a customer, they want to understand the way that the product was sized, you can go through all these calculations. If you need anything else, feel free to give me an email or call me. Both information's there. And if you want to size another one, just click right here and you're ready to go at it. I hope you enjoyed it. Look forward to your feedback and comments. Happy sizing.